Hi, everyone. This is another CODEstantine online meetup. Today we have Andrei Pfeiffer with us. And before we go into his topic of isolated components-driven development, let me just share a couple of words about CODEstantine and No Limit Hub, the NGO which is behind it. As you probably already know, my name is Nikola Cvetkovic. I'm the founder of Emito, the multi-channel no-code business messaging hubs, which allows you to send business messages via SMS, Viber, and many other channels, all from a no-code interface, as well as Product Hive, a SaaS product development agency. And your host today on this topic. We will be, as you probably already know, CODEstantine has a lot of interesting speakers already lined up for the next couple of weeks. So go to CODEstantine, so CODEstantine.com, and check out the upcoming events as well. Sign up for those and make sure you don't miss awesome speakers from all over the world, which are coming to share interesting developers topics. And we'll be doing this. We're preparing a live event for later in this year, hopefully as well. So these meetups are kind of warm-up session for the actual event that's coming later in the year. So make sure you follow CODEstantine and No Limit Hub on different channels as well. So I want to welcome you all to today's lecture about isolated components-driven development. We have Andrei Pfeiffer with us, coming from Romania, Timișoara, and in this talk, he will describe the challenges of developing UIs that are integrated with complex external APIs. So using tools such as React Styleguidist or Storybook, eliminate the need for an integration, enabling us to develop components in isolation outside of our applications. So these techniques enable more flexibility during development and debugging, will also provide a living documentation for the UI components. And I think that this topic is super interesting. So everybody who works in React, everybody who works on front end, in general, I think should be aware of these tools and this kind of processes. I think this is more about process than anything. Processes are smooth, which is kind of a prerequisite for the high quality front end development. And just a couple of words on Andrei. He's a code designer who develops websites and web apps since 2000s. And went through all the stages of web development from HTML3 and jQuery to HTML5, ES6+, TypeScript, and beyond. So Andrei currently works as a UI engineer, switching between web and mobile. We have one guy just like you who does that and who will be sharing one of the talks in the upcoming weeks. So I feel your pain and I understand your process. That's an amazing thing, switching between React Native and web. So that's an interesting topic, maybe for some other time. But like the overlap and kind of the cross knowledge between the two is something that definitely is also an interesting thing to discuss maybe sometime in the future. And so your everyday battles resolve around clean code design, user and developer experience, interaction and design, and fighting software entropy through constant refactoring, code reviews, unit testing, and team collaboration. You're highly involved in tech community, being a co-organizer of Revo.js conference and a Tim.js meetup. So you're a fellow developer community member. So thank you for doing all that for your community. As you know, CODEstantine started off as a developers community in Niš, south of Serbia, but we're kind of expanding our reach and kind of taking this advantage that everybody need to speak online to kind of reach maybe a little bit wider audience. So we're also happy to recommend some of the speakers for your future events. So if you need feel free to reach out. Happy to help if we can. And without further ado, I have a tendency to sometimes speak a couple of minutes when we start. So sorry for that, and to you and to all the people who had to listen to this. But we do have to make sure that you follow No Limit Hub and CODEstantine on all the social media, subscribe everything, and make sure you go and sign up for all the future talks as well. So Andrei, without further ado, isolated component-driven development. Go ahead, it's your topic, and I'll be jumping in and asking maybe some questions. Everybody can leave the comments on the right in the events section. We might run a couple of polls or Q&A sessions later, and we will have a short networking session at the end of the talk. Andrei, now seriously, you can take it. I'll even mute myself and turn off my video for a few seconds to let you to cool down from my face. Go ahead, and thank you for being here.
Thank you. Please just let me know if you can see my screen.
Yes,
so we make sure that I'm not talking like a radio on a blank screen.
You're not. We do see a screen.
Okay. Thank you, Nicola, for the introduction and for having me as a speaker at the CODEstantine. It's really an honor for me to be here, and thank you everyone for joining this session. Just one thing to mention: this talk is not limited to React. So the core idea of the talk is basically applies in any framework with or without a framework, actually. So isolated components driven development. Before we start the talk, I just want to mention that I have some animated transitions and some contrasting colors like the one that you see here. So if you are suffering from epilepsy or some sort of epilepsy, just please be aware of this thing. Okay, so what we're going to cover in this session is what is this isolated component driven development? Why should we care, and when should we apply this technique? And we will also take a look at like a very high level how to apply this technique, but the focus is not on the how, it's mostly on the use cases where this technique really is useful during development. And again, let's focus on the who for a minute. As Nicola mentioned, my name is Andrei Pfeiffer. I live in Timișoara, which is a fairly large city in the west part of Romania. We are neighboring. I live very close to Serbia. I like to code and I like to design, and I also like to design code. So that's why I call myself a code designer. And I'm focused on UI engineering, front-end development, both for web and for mobile. As Nicola mentioned, I'm also I organize Team.js, which is the local JavaScript community here in Timișoara, and also Revo.js, which is an annual conference, a two-day not-for-profit event that hopefully we're gonna be able to organize next year. We had to skip last year. We had to skip this year, but hopefully next year, the third time, should be a lucky number. I also published recently my website and my blog, andreipfeiffer.dev. So please check it out and subscribe if you want to follow the upcoming blog posts. And you can follow me on Twitter. My handle is Pfeiffer_Andrei. Pfeiffer is my name is spelled just like Michelle Pfeiffer's name. Okay, so let's jump into the topic. So what is isolated components-driven development? First of all, it's not another methodology or technique that follows TDD or BDD or ATDD. It's something completely different. It's basically a technique that helped me a lot during development, mostly in development, but also during debugging of UI components, being UI engineering. Of course, I applied this to UI components mostly. At a very fundamental level, we can think of a component, of a UI component, as a function of props, right? React popularized this idea. And if a component is a function of props, then we can take that function and execute it, not necessarily inside the application, but outside the application, just like in unit testing, right? We basically employ the same technique during unit testing. We take one function or one method, and we execute it outside the entire application, not to rely on the whole system to be running just to execute a simple function. Basically, the core idea of this technique is this simple approach, and we're gonna get to more details later. Some use cases. When is this approach useful? When should we and why should we render components, UI components of the application? Well, there are multiple situations where I found this really helpful. The first one that comes to mind is when we have to build a components library. When building a components library, usually these libraries are developed separately from the application that uses those components. So we don't have like an environment or a place where to render our components. So in basically the nature of this components library requires us to use such a technique. So in order to develop the components, we need to render them somewhere. So we have to render them in isolation because we don't have the application to get them running into, right? We need somewhere to render the components. So this technique is required when building components library. Another use case that I have encountered 2 times in the past was during the development of what I call read-only UIs. So what are these read-only UIs? Well, in UI development, most of the time we are communicating with an API to make some requests, and the API itself communicates with the database as a persistence to store the data and to read the data from, right? So during the development, most UIs are CRUD interfaces, right? They have all these CRUD operations: create, read, update, delete. And to be able to develop components, first we need to add some data. So the create operations really help us here. And then we read data to display on the screen and to be able to develop those components. Without being able to write or to create these the data from the interface, we wouldn't be able to develop like stateful components, right? Only empty states, for instance, for the components. So this is really convenient when considering CRUD interfaces. So just to keep in mind, the blue arrows are read operations, the orange arrows are write operations. Now, there are some UIs that only read data, only display data, and the data comes from an external source. Like it could be like a very complex system, very complex architecture that actually puts the data in the database. So we cannot add new data from the UI. Such applications or such examples of such UIs are Google Analytics, for instance, or GitHub. When we look at the diff of a pull request, for instance, the pull request comes from a totally different data source, right? We cannot, we don't create it from the interface. We cannot add data from the interface. And developing such interfaces is really problematic because how do we add the data in order to work on the interface? Like it's really, really difficult. Even if we have access to the other APIs or services that actually add the data, it could be really cumbersome and not easy to perform. So employing this technique when building such interfaces, like to take the components of the UI or to isolate the UI from the entire system that actually puts data, and to be able to inject or to stop the data that we actually need during development is proves to be really, really easy and improves the such interfaces. A third use case is when we have to work with unstable web APIs. So let's consider how would we connect our user interface to an API. Let's say that we don't have a read-only interface, right? We have a CRUD interface, so we don't have the problems I mentioned previously. Well, from my experience, I have experimented with 3 different ways to connect a user, a UI, like a front end of an application, with its corresponding API. The first method is having a remote development server. So what I'm running locally is only the UI, only the user interface, the front end, or how you want to call it. And the API and the server is basically on a development server somewhere remote, and I just connect remotely to that server. This is pretty convenient because myself, as a UI engineer, I don't really want to have complex local environment server kind of stuff, because I'm not really good at those things. So for me, it's really convenient to have somebody else take care of the deployment of the API on a server, and I just connect to it remotely. It's really convenient for me. It's easy to share data between all the developers working on the same application, because all the developers would basically use the same development API, the same database. So all the state is shared with all the developers working on it. Now, this could be, of course, a problem, because you could delete one of the data of your colleague, for instance. But it's really convenient to tell a colleague of mine that can you please test a specific scenario with this data that you can find somewhere, because all the data, like the persistence, is shared with everyone. So it's very easy to have the same application state for all team members. Now, the problem with this approach is that you depend heavily on the infrastructure. So, for instance, the API might be down, right? Somebody messes up the build, and the API is not working. So you cannot do any development, because you cannot work on the UI because you depend on an API that's offline, is not working. Also, another problem is that it's difficult. You cannot deploy different branches on the same API, right? You have only one server. Usually, you have the integration branch deployed there, develop branch, or whatever integration branch you are using. So it's not trivial to deploy a different branch if somebody wants to. You have to scale up, you have to have different servers, and to somehow manage the deployment of different branches on different servers. So it gets could get really complex in this regard. Also, you need an internet connection, right? You cannot work offline. So you have to keep this thing in mind as well. Well, to overcome all the limitations of the previous method, we can have a local API setup, right? To have the entire servers running locally on our machine. Now, as a Docker and containerization, the containerization technique definitely made this a lot easier. So you could only run a few CLI commands, and you could have an entire infrastructure running locally on your machine in just a few minutes. So it definitely helps. You can work offline using this approach, right? Because everything is running locally on our computer, which is great. We can easily switch branches on the API as well, because we are controlling what's running locally, right? So we can, for instance, do any regression testing, or to check out a previous version of the API to see if a bug replicates on a previous version. So we have all this freedom regarding the API. Now, one downside is that it's not easy, it's not trivial to share data with a colleague of ours, right? In order to do that, because the entire database and the entire persistence is on machine. So in order to tell somebody, hey, could you please test this scenario for me, you would have to basically either explain to that person like how to get to a particular application state in order to replicate a specific use case, or to export the entire database, send it over Slack or email or whatever communication channel we're using. And then they would have to import it in their own local API, but that would basically delete the entire database that they already have. So yeah, it's not trivial to to share data between colleagues. Also, we need to perform ourselves the entire system setup and any migrations or any updates to dependencies. So we have to manage all these things ourselves, and basically each team member will have to do that as well. So it's a bit more difficult to do. Also, if our API communicates with some third-party services, we'll have to add the mocks to those services in order to have this offline functionality and not to rely on third-party services. So that's another thing to keep in mind. So pros and cons, right? A third approach that I tried is to have a fake API running locally. So we could have like a shared development API, but we can also add like a proxy, sort of a proxy server that's running locally on our computer, which intercepts, or we just redirect the request to a fake API that's running on our machine, and we basically can easily stop or intercept the request and just send like a mock data, whatever data we want basically the request to respond with. This is, of course, this works offline. It's fairly easy to, it's fairly easy from this point of view. The data is the data that the API responds with is really easy to set up. In contrast with the previous methods, where we basically need to perform all the actions, and the API would respond accordingly if all the application state is the required application state. But having a fake API, we can easily stop or mock any request directly, without doing any additional setup, which is like really easy and really powerful. The problem with this approach, of course, there's a problem with this approach as well. There is a maintenance cost that we have to pay because it's a duplication of a real API. It's not a real API, it's a fake API. We have to duplicate the endpoint, and we have to basically specify the request, the shape of the response that it outputs, right? So whenever the real API changes, we have to make changes to the fake API as well. So this is something that it's like a duplicated amount of work that needs to be done on the long term. So integrated with web APIs is not always trivial, and the idea is that we don't need to rely on external APIs in order to develop UI components, as we shall see in the upcoming slides. Another situation would be data-dependent components or containers, for instance. Let's say that we are not building components library. We are not dealing with a read-only interface. We have all the API setup is really simple, right? It's working, it's always online, and it's fairly easy to work with it. Now let's take a trivial example of the development of a single component. So we have let's say an application, right? We have an app shell, and then you have some routes. So in order to develop like one single component, we'll have to travel to navigate to a route, and then that route would probably request, get some data, pass it down to other components, to a container component. That container component will also make another request to the API, which in turn could access some third-party service, and then basically display a component, and that we need to develop or to debug. Doesn't matter. What we want to do basically as UI developers, we want to work at this component deep down in our application tree, right? But we have to have the entire application running, we have to have the API running, and we have to have the third party running. So if you think about it, you want a banana, but along with that banana, you get a monkey that's holding the banana, and the monkey sits in a tree, and the tree is part of an entire jungle. So you want one banana, and you get the monkey and the entire jungle of trees, because yeah, that's how this works basically, right? So it doesn't have to be like this. It doesn't have to be that difficult actually. So the core of this talk, we want to isolate stuff. We want to, first step is to isolate the UI, right? To not rely on APIs and any persistence and any third-party web services. That's the first step, right? Isolate the UI. But we can go one step further and isolate the component from the entire application and just work on that single component. As I said, just like we do when in unit testing, right? So let's focus a bit on how we can do this. How can we apply this technique? Well, the easiest approach would be to basically build our own solution. I have recently done that on my website. It's just a simple website, but before building any pages of the website, I have built this page, style guide, which is a regular page just like the others, but has all the components or the building blocks of the website that I was going to build. So I didn't start building any page until I developed all the components required to build my website. So I have some typography, right? I have a few colors here, some combination of colors, spacing. This is a spacer component with different values, some layout components, inline elements, text elements, alignment, grid, and some interactive elements. So I haven't used any tooling, and you don't need to use necessarily any tooling in order to use this technique. It's just basically you render the components outside their exact usage or their final usage. Now, this works for very simple websites or applications or personal projects like this one, but it doesn't scale up when you think about larger teams or bigger projects. So we probably should use some tools in this regard. There are many tools that help us developing components, UI components in isolation. Storybook, Docs, React Cosmos, React Styleguidist. Docs, for instance, Docs and React Cosmos, I have only played with those. I haven't used them on real projects, so I won't go through them in detail. Docs is focused on documentation mostly. React Cosmos is focused on development, on the development of the components. So as I said, I won't focus on them because I haven't worked with them, but I have used Storybook and React Styleguidist on multiple projects. Storybook is an open source tool for building UI components and pages in isolation. That's a quote from their website, while React Styleguidist is an isolated component development environment with a living style guide. So as the name implies, React Styleguidist is specific to React. Storybook is a framework agnostic. So this is one very big difference between the two solutions. I'll go very quickly to an example on how we can document or how we can write component examples. So with a Storybook, you would create a new file, typically a JSX file, or you can give it any .stories suffix here as well. So you would have to import your component, which usually resides within the same folder. We'd have to do an export, a default export with the name of the component, which is the component that the source component that we have developed in a separate file, and give it a title. This is used just to group components, some components together. Then we can create a template and to reuse that template to write some examples. For instance, we can have this example here, which is a primary button. And we can specify the input or the props or the arguments for that component, which is primary true, and children is the text submit to render a primary button with the text submit. So that's like a really simple overview of how you define an example in using Storybook. With the React Styleguidist, we have markdown files, which is like a very different approach than Storybook. It's a markdown file typically with the same name as the component name, and inside that markdown file, inside the code block, markdown code block, we just describe how we want to render the component. This is a React syntax, so yeah, it's just plain. The code of the component as you would write it in JSX. So it's a less boilerplate. It's much more simpler, but it doesn't have the power of JavaScript, because here we have JavaScript code and we can do all kinds of crazy things with Storybook. Let me show you quick what you get. So this is an example of React Styleguidist. So the entire the tool basically creates this UI. All the components that are found are listed on the sidebar. And here, for instance, we have a button component, and we can see the list of props. This is read and displayed from the component automatically, either if we use TypeScript type definitions or the prop types as they are by default in React. So it can read the prop names, the type, default value, and if we have a case of if we have a prop that's a union, or it has different values, an array of values, they are displayed here as well. We also get how the component is rendered, and it's basically this is interactive, because this is the actual component that is rendered in the UI, and you have the code that renders these components. And this is what is pretty nice is that this code here is interactive, so we can mingle with it, right? We can update it and see the changes reflected in real time. We can change props, right? And yeah, we can do all these different things here. So we can play around with those here in this playground, which is really really nice. And we can have the whole list of components that's listed here, similarly as you would see in or as you would expect in any component library like Bootstrap or Material UI, and so on and so forth. Let's look at Storybook. Storybook has a similar interface. We have a list of components listed here with different variations. Now, the Storybook interface changed a lot from version to version. This is the latest version, version 6, which changed a lot, actually. I've used Storybook 3 different versions, and the last one really is very different than the others. It comes with a lot more functionality out of the box than previous versions. So we get this basic component here, and we get these controls at the bottom. So we can mingle with these values here as well. And the component gets updated in real time as well. We can change different props. This is also automatically generated based on the prop types or prop definitions in TypeScript. It's really, really awesome. In previous versions in Storybook, you would have to manually add these controls here. But since version 6, this is done automatically, which is great. It puts some toggles here, right? You can see loading because I toggled the is loading boolean. So yeah, we have this nice interface that allows us to mingle with the props. And also since version 6, I think, or 5, I don't know exactly, you get this docs page, which lists all the components on one page. Instead of when you look at the canvas, you see only one set of one story at a time. These are all stories. That's how they are called in Storybook. You also get like different add-ons to with the Storybook. You can, for instance, change the background to have a light or dark background. You can see, you can have this different viewports, or I don't know how. Yeah, this is a grid. I don't know what's useful for, but you have all these different different add-ons that enhances the functionality and the UI of Storybook. But as I previously mentioned, the core of this talk is not on the tooling, on how to build components in isolation. There are the documentations for Storybook and React Styleguidist are pretty good, pretty thorough, and there are so many tutorials out there. And I mean, if we get into the details of how to build, how to use these tools, it would take forever because there are so many different approaches. So let's get back to the presentation and let's see an overview of these two tools. So first of all, as I said, the official integrations for React Styleguidist is only for React. There is a fork for Vue. I haven't for Vue.js. I haven't used it, so I don't know what to say about it. As for Storybook, the official integrations are for React, Angular, Vue, and the web components. But there are community integrations for, I think, most of the frameworks that you would probably work with. I can show you really quickly on their website. You can see here the core integrations and the community integrations, Ember, HTML, Mistral, Marcos, Velt, and so on and so forth. So we have a lot of integrations. How do you write examples? Well, in the React Styleguidist, as we saw, we use Markdown. It's a special kind of Markdown with some black magic behind the scenes, because we can also write some JavaScript code inside the code blocks, but mainly it's Markdown. With the Storybook, we could write them in JavaScript, in TypeScript, or we can also use MDX, which is JSX with Markdown, or Markdown with JSX. Which is like a Markdown on steroids. So this is like one big difference between the two. React Styleguidist keep it very simple and basic, straight to the point. Everything is declarative. With Storybook, you have much more flexibility because you can use a programming language to describe all these examples. So with great power, flexibility. Plugins, Storybook has a lot of plugins. I won't go through the list of them, but you can check out their website. There are many add-ons that you can use Storybook in conjunction with Jest tests. You have some accessibility tooling. You have all kinds of add-ons that can enrich the UI and I don't know, the whatever you can do with the Storybook. React Styleguidist, there is a pull request, or there is an issue regarding this, but it's stale, and I don't think that they are going to add plugins anytime soon. Now, the primary purpose, or the main purpose of React Styleguidist was documentation. Not necessarily the development or to help during the development of components, but I have used, I mean, it helps you during development as well, but you don't have all the tools, or all the whistles to help you during development, as Storybook does, for instance. Now, Storybook, on the other hand, started as primarily as a development tool or development-focused tool, and not necessarily as a documentation tool. Since version 5 or 6, so the latest versions, also added a lot of documentation support. So now it's very easy to use it as a documentation tool as well. So from this point of view, Storybook is more versatile, but it's more bigger and more complex than React Styleguidist, which is really focused on documentation. But also during development, it can help us a lot. Regarding TypeScript support, Storybook has full TypeScript support because we can write examples in TypeScript, with the exception when we choose to use MDX. MDX doesn't support TypeScript or type checking, so that won't work. With React Styleguidist, since we are using Markdown, we also don't get type checking in the examples. It can understand the components written in TypeScript. It can read the type definitions for the props, but inside the example that we are writing, we don't get any type checking, which is a limitation. That's, yeah, for me, is a bit frustrating from this point of view. Now, one thing that is worth mentioning is that there is no black or white in regard to using this technique. We can employ an incremental adoption, so we don't have to go like all or nothing when we are thinking about isolating component-driven development. So the first step that we could do is basically to use one of those tools, or any tool basically. We can install it locally or set it up locally and use it when needed. So for instance, when we are working with an API that may be unstable or is difficult to get our application to a specific state in order to render some state of a component that is very deeply nested in our application tree, we can render that component outside the application using these tools or using such tools. And that's it. It helps us during development or during debugging. If we need to reproduce a certain scenario where it's very difficult to get the entire application and the API in a specific state, you can just render that component, pass it the props that is required to reproduce a specific bug, and that's fairly easy. We don't have to I don't know, to enforce the tooling, so and everybody's is using it. So we can start small, right? Then at some point we can commit it and check it in the repository and share it with the team. So other team members could also benefit from the documentation that we provided when we built when we wrote the examples for those components. So in step 1, we used the tool only for development purposes or debugging purposes. In step 2, we are also using it as a documentation tool, right, to help others and others to develop as well, so we can benefit from the documentation also. Now, as a third step, we can publish it online as a static build. Both Storybook and React Styleguidist have a CLI command that allows us to build or to create a static build of the UI, which we can deploy and publish online. So others, non-developers, can benefit from the documentation as well, like designers or testers or product people, right? So we can employ these steps incrementally. There's also some additional benefits that come along. Now, usually when we are working on larger components or pages or whatever we want to call it, we don't work with small components. We work with very big components with a lot of code, right? It's very difficult to focus because you get all this code at once on your screen. And let's say you are working inside this big chunk of code. It's difficult to focus on that particular component or that particular code that you are working with. It's difficult to do that because you have all this surrounding code. Sorry?
Yeah, nothing. Keep on.
Okay. Okay, so
usually I'm jumping in way more, but it's super clear and concise, and I don't want to interrupt the flow. So
okay. No problem. Cool. So as I was saying, having all this surrounding code is just like looking at a forest full of trees. So you cannot focus on a particular tree and take care of one particular tree because all of them look the same, and it's difficult to focus on one of them. When we take this component we're working on and we take it out of the application and we develop it separately in isolation, it's just like taking care of a bonsai tree, right? We have our entire focus only on that particular tree. So it's of course we can take much more care of it if it's isolated from the entire forest. And it's difficult to see the flows of a component if we are basically the one who builds it, if we are really deeply into the guts of that component. Think of it like it's impossible to see the shape of a building if you are in the city, if you are at the base, if you are inside the city. You have to step out of the city in order to see the shape of the building, right? So when we take the component outside of the application, very interesting thing happens because we get to experiment the consumer part of the component, not only the authoring part of the component. So we can see how it is actually used, because when we write those examples, we actually use the component, right? We are the consumers of the component. So we can see all the flows. We can see probably the names of the props are not as perfect. They could be improved. The types of the props, the values that they receive, the name of the component maybe is not very intuitive. So we get to experiment how the component is actually used by any consumer, which really improves the component's API. This is like a personal observation that I have, that I write better components when I develop them in isolation. As I previously mentioned, you get shared documentation out of the box that you can share either privately with the developers or publicly online with all the interested persons. You get interactive playground, right? Unlike the examples that I showed you were on my website, where I just created like a page, and I only saw the rendered part of the component. So I only saw the components rendered, but I didn't see the code that generated those components. So I had to go into the source code in order to see the example or how to use the component. But with these tools, you get the interactive playground. You can mingle with the component. You can see how it is used. So yeah, it's really powerful. It also forces us to think about or to employ this separation between container components and presentational components. Because, okay, writing or adding leaf components or dump components in this or developing like very basic components that only get an input and fill out some content, that's fairly easy to do, just like unit testing, right? Unit testing pure functions is fairly easy. Everybody can do that. The problems arises when you have to deal with stateful functions, right, or stateful systems. When we have to deal with more complex components, with smart components that read data from an API or reads from a store, Redux store, a Mobile store, or whatever, that could be more tricky. These tools, both to inject any data provider that you might have in the application, to inject a Redux provider or a Mobix provider, and to inject mocked data for the stores. So you can do that as well. But it's a bit more difficult. It's a bit more boilerplate to write, but you can do that. On the other hand, we can separate, and this is a fairly common pattern both in Angular and React, to separate the container, which is the part of the component that reads data and fetches the data and stores the data, to separate that from the presentational part of the component, so how the data is displayed, right? And we can only use or add in this, develop only the presentational part of the component, because that's really easy to, it doesn't depend on any external data source, right? So having this separation benefits also the development of the applications, but is also, when we employ these isolated components-driven development, it also forces us even more to employ this pattern. So this is also a nice thing to keep in mind. And last but not least, this could grow eventually into a components library or a style guide or even a design system, right? Because you can also, both Storybook and React Styleguidist allow us to create static pages, not necessarily to render components, but we can create static pages with some text or whatever in order to be the basis of a documentation for a style guide. Yeah, it's easy. It's fairly easy to from the implementation point of view to evolve into this state when you actually have a design system and a living style guide, because usually design systems and style guides are placed inside prototyping tools like Zeppelin or InVision or that kind of stuff, but those don't reflect what is actually implemented, right? With these tools, you get a living style guide because everything reflects the implementation. So whenever the implementation changes, the style guide updates as well, and that's the real truth. You can see basically the truth of the single truth, like how the component is behaving and looking at the moment. Great. So this was it on my part. I have some credits to give to Flaticon, which helped me to use some icons, and from Pixabay, I used from some images from Pixabay. I thank you very much for joining this session. You can check out my website, as I said, andreipfeiffer.dev. I will publish in the upcoming days or weeks an article, 2 articles regarding this topic. So if you want a TLDR, right, you can to share with others, then please make sure to subscribe. Yeah, thank you so much, and looking forward to any questions that you might have.
Awesome. So I usually jump in way more than I don't think that I jump in on purpose, at least through this talk, because it was very well kind of structured and kind of explain things clearly, I would say. I do have a couple of questions just to kind of make sure to clarify on something, but I will also kind of ask people to write down the questions in the chat as well. So this is your chance, so shoot away. I have a couple of questions, so I'll start from the back. From the back. So usually how it goes, and you mentioned this, usually there's like a design system that comes from a designer who creates something, and then it goes into development, and then usually the design system from a designer is used as a kind of the truth of what's there, and it does create some problems later on in production, and especially for developers, and like things keep changing on the fly sometimes. However, we want to stick to the design system. Some things change. There's some specific cases which kind of need to be handled. So like, how do you advise to approach this in the best possible? So like, would you say that the development system should be the kind of the main thing that the designer should basically look back and kind of update their design as kind of the primary truth, and how to kind of handle that kind of constant battle? And the other question on that, like, how do you handle the kind of interconnection of styling between the components, and like the paddings and the margins and like things moving around when you start adding isolated components? I see that as kind of the primary issue with this system. It looks and works great when it's on its own, but then you might need to change the core of it sometimes to make it fit where it needs to fit. So like, can you answer these two questions to start?
Yeah. Yes, both questions are related to how to build a design system. So the first one, I have worked on many design systems, and it always like depends on so many different aspects. So from my point of view, I have worked with many designers. Some designers were, or let me rephrase that. I've worked with some very pixel perfectionists, and even those pixel perfectionists weren't 100% accurate and precise all the time. So as a UI developer, I don't expect a design or a designer to provide something that's perfectly accurate. That's my my starting point. So because let me give you a simple example. Let's say that the design system that was thought and designed and implemented by a designer tells you that we have certain spacing values, multiple of 4 pixels, for instance, 4, 8, 12, 16, and so on and so forth. And at some point, you would see a spacing in a design that he made of 6 pixels. Now, there are two possible situations here. So the designer did that on purpose, or was it a mistake? A developer that follows whatever he receives from the designer would implement that 6 pixel spacing, even though probably the design system doesn't or forbids him to to do that. So you don't know whether it's a bug or a feature, right? So it's always this. The only thing that works from my point of view is communication, right? With you solve so many things with communication, and I think almost any time or every time that such an event occurred, the designer said, "Oh no, it's not 6. Of course, we said previously that it's 4, 8, and multiple of 4s, right? Just 6 there." So I forgot my train of thought for a minute, but as a general rule, I treat whatever I receive from a designer as a guideline. And if there's something that doesn't fit if it doesn't fit the system that we agreed upon, then definitely we need to discuss. Okay, there is this thing here or this situation that doesn't correspond with the system that we agreed upon. Do we need to change the system, or do we need to adapt your design according to the system? So only through communication you can find the right answer from my point of view, or that's how I treat these situations.
Cool.
And in regard to the source of truth, like, of course, at the beginning you get the source of truth as being the prototypes that are built by the designer, right? And but you would move that source of truth if you employ such technique, or if you start to develop this component library, or there's a difference, by the way, between a component library, style guide, and design system. There are different things, but I won't go into those details. But at some point, you move the source of truth to the implementation, because that's the actual truth, right? And for instance, the guys at Seek in Australia, that Mark Dalgleish, I don't know if I got his name correctly, but they say that they use what's the tool for Mac for prototyping, for using, I don't know, there's some really popular tool. They basically used some custom built tool to export the React components. They use the React in the application to export or to transform the React components that are basically developed for the application, to transform them into components that are used by the design tool that the designers used. So they basically, the designers used exactly the components how they looked in the implementation. If you understand my my explanation. Yeah, so it's, at some point you need that if you want to be very accurate about what you are building. But yeah, that's what they are doing is like extreme from my point of view.
So you mentioned a couple of different approaches when it comes to kind of mocking, not mocking the data, but using the data and building the component to work with data. What is your go-to approach in most cases? So like, do you mock the APIs? Do you use the real API? What's your usual kind of, if all things are there equal, as kind of in most cases the API is available, etc. Like, what do you go for?
Of course, like any wise answer, it depends a lot. I prefer to have, as I said, I prefer to have a server. I really prefer that. I am running only the UI locally, and that's it. And somebody else takes the backend development team or the infrastructure team. They take care of the deployment of the API and everything. For me, that's very convenient. Now, if the API is unstable, right? I had some such situations where where we had this development server, but the API was unstable. It had to communicate with some third-party services that were unstable, or it basically was a build error, and it took them a few hours to fix. So the development server wasn't working. So at that point, I started building also a fake server. So whenever the API was down, I would start up my new server just to have a backup in case the development server is offline. With a fake server, it's very convenient to make during development, but it doesn't guarantee integration, right? It's the same discussion like, okay, do you do unit testing, integration testing, or end-to-end testing? With unit testing, they run very fast and very easy. They are very easy to do, to write and to implement and to run. But it doesn't guarantee that all the individual pieces that work fine in isolation, they would work fine together. So there is this engineering trade-off that, yeah, we have to take into consideration. Of course, at some point, you would need to make the integration as well. So having a remote development server, or the production server, or whatever server that is deployed somewhere on a real machine, you would have to integrate with that as well, right? But having also a fake server to help you during the situations where the development server is not available, or for some reason, it won't block your development on the UI just because the API is not available. So there is this situational scenarios where one approach is better than the other.
You maybe forgot one case there when you're actually using some other call that you already have from the same API, but which returns a completely different thing, to just use it as kind of the placeholder for loading states and stuff. And
exactly.
That happens a lot as well while waiting on backend.
Exactly.
Cool. So, one more, my final question, and if there's no more questions, I see everybody's saying that it was a great talk and giving thanks and praises. But if somebody has a question, now is your chance to ask it. Just the final one on the two different tools that you mentioned. So like how much, because I'm not sure if that everybody got that from the talk, how much of the actual extra work is needed to build out the library? Let's say we have an app that we've been working on, it's in React, and like we have it structured in a way that there are components, for example, different components already kind of split out. Like how much additional work is there needed to kind of have it all displayed in a component library with both of these tools? Not trying to get you back to the whole discussion of what's possible, and not like just in general to get a kind of high level feel of the extra work that's needed to get to that state.
It's a very difficult question because it depends a lot. I will make a side note here. So the first open source library that I built many years ago, I worked 2 days on the actual source code for 2 days, and 3 days I worked on the documentation for that library. But I wanted to be like the ones that I like, the documentations that I saw on other libraries that I enjoyed, So I wouldn't say that in this regard the documentation part takes more than the actual source code. I really don't think so. But I mean, if you use it, if you don't put that effort into the documentation, like on the wording, on how to structure the examples, or how to give to provide all the combinations and all the relevant combination of certain props. So if you use it only for development purposes, where nobody else, for instance, is going to use it, or to run it, or to inspect it, then the amount of effort is basically minimal. I don't know how to, I don't know, let's say that you are working 1 full day at the actual component, like writing writing the documentation could take I don't know, 10% of the time, right? But it could also take 50% of the time, because you wanted to make it intuitive and self-explanatory for others. So this is it could depend a lot in this regard.
Cool.
But keep in mind that only working on a single component, like, it could take you a lot just to get your entire application to that state that is required to develop that component. So in this regard, using this technique could save you like a lot. You don't need to do all the, I don't know, clicking, going to routes, fetching data, waiting for the API, that kind of stuff. So this is where it really comes. It's very handy in these situations.
Cool. We have Nemanja Jocic asking for about the component development process. So what does the component development process look like? Do you develop components directly in Storybook?
Yes, most of the time. So in the past years, basically, I would just like, it's not like an actual TDD, but there is the ideology to write your test first before the source code, if you know what you are building. So basically, I'm taking the same approach in regard to UI components, because I know what the component should do from the designer, and I know what it should do, right? Because I have the specifications for that component. So I know everything about the component, so I can develop it in isolation. I don't even put it into the actual page or the actual source code where it will be needed or used eventually. I just develop it in Storybook or React Styleguidist or whatever tool I'm using. It doesn't matter. And I use it there, and I can try out all different kinds of props and combinations to see whether it works. It combines well together, and only after that, after everything is very clear, I get to experiment with the component. I get to see the API, how the props are named, what the types are, and after everything is fine and dandy, then okay, I can use it myself, or if I build it for others to use, others can take it and use that component. And this is I mean, mostly this applies to reusable components, so the abstract components that are used throughout the application. But I also use this technique for specific components. Like if I know that, okay, I have this, let's say, a model that is specific to a single page, that the model has to receive some data to display in a complex dropdown and to get some validation based on different props that it receives, then I can develop this whole big component. Like, it doesn't matter how small or how big the component is. If I can pass it the data to get rendered accordingly, then I can move it out and develop it in isolation. And it's for me it's a tremendous. It helps me a lot. I don't know how to express it, but it changed the way I basically develop interfaces.
Cool. Thank you, Andrei, for the wonderful presentation and a really good overview of this process and these tools. I just want to thank all the people that were listening to the talk as well. Make sure you go to CODEstantine.com and sign up for future meetups.